Welcome back to Mining of Massive Datasets. In the previous section, we studied the MapReduce model and how to solve some simple problems using MapReduce. In this section, we're going to go under the hood of a MapReduce system and understand how it actually works. Just to refresh your memory, a MapReduce system has a simple MapReduce process has 3 steps. In the map step, you take a big document which is divided into chunks, and you run a map process on each chunk. And the map process goes through each record in that chunk, and it outputs intermediate key value pairs for each record in that chunk. In the second step, which is a group by step, you group by key. You bring together all the values for the same key. And in the third step, which is a reduce step, you apply a reducer to each intermediate key value pair set, and you create a final output. Now, here's a schematic of how it actually works in a distributed system. The previous schematic was how it worked in a centralized system. In a distributed system, you actually have multiple nodes, and map and reduce tasks are running in parallel on multiple nodes. Here a few chunks of the file, input file, might be on node 1, a few chunks on node 2, and a few chunks on node 3, and you have map tasks running on each of those nodes, and producing intermediate key value pairs on each of those nodes. And once the intermediate key value pairs are produced, the underlying system, the MapReduce system, uses a partitioning function, which is just a hash function. So the MapReduce system applies a hash function to each intermediate key value, and the hash function will tell the MapReduce system which reduce node to send that key value pair to. Right? This ensures that all the same key values, whether they're in map task 1, 2, or 3, end up being sent to the same reduce task. Right? So in this case, the key K4, regardless of where it started from, whether in 1, 2, or 3, always ends up at reduce task 1, and the key K1 always ends up at reduce task 2. Now, once the reduce task has received input from all the map tasks, all the map tasks have completed, then you can start the reduce tasks. And the reduce task's first job is to sort its input and group it together by key. And so in this case, there are 3 values associated with the key K4. They're all grouped together. And once that is done, the reduce task then invokes the reduce function, which is provided by the programmer on each such group, and creates the final output. Okay. So remember, the programmer provides 2 functions, map and reduce, and specifies the input file. The MapReduce environment has to take care of a bunch of things. It takes care of partitioning the input data, scheduling the program's execution on a set of machines, figuring out where the map tasks run, where the reduce tasks run, and so on. It performs the intermediate group by step. And while all this is going on, some nodes may fail, and the environment makes sure that the node failures are hidden from the program. And finally, the MapReduce environment also manages all the required inter-machine communication. So we're going to take a look at exactly what's going on in a little bit. So let's look at the data flow that's associated with MapReduce. Now the input and the final output of a MapReduce program are stored on the distributed file system, and the scheduler tries to schedule the map task close to the physical storage location of the input data. Now, what that means is that, recall, the input data is a file, and the file is divided into chunks, and there are replicas of the chunks on different chunk servers. The MapReduce system tries to schedule each map task on a chunk server that holds a copy of the corresponding chunk. So there's no actual copy, data copy associated with the map step of the MapReduce program. Now, the intermediate results are actually not stored in the distributed file system, but stored in the local file system of the map and reduce workers. What are intermediate results? Intermediate results could be the output of a map step. An intermediate result could be something that's emitted while in the process of computing a reduce. Now, why are such intermediate results not stored in the distributed file system? It turns out that there is some overhead to storing data in the distributed file system. Remember, there are multiple replicas of the data that need to be made, and so there's a lot of copying and network shuffling involved in storing new data in the distributed file system. So whenever possible, intermediate results are actually stored in the local file system of the map and reduce workers instead